In this video, I will discuss the solution to question 1 from homework 5. We have been given that x and y are independent with fx of x is equal to u of x minus 1 minus u of x minus 2, and fy of y is equal to u of y minus u of y minus 1. Z is equal to x plus y. Find fz of z by convolution method, where fz of z is equal to fx of z into fy of z is equal to minus infinity to infinity fx of alpha into fy of z minus alpha d alpha, and to the geometric method. So by solving this question by convolution method, so for fx of x is equal to u of x minus u of x minus 1, we get this graph. For fy of y is equal to u of y minus u of y minus 1, we get this graph. And by shifting the result by right, for fz of z, we get this graph. So applying the convolution method, fz of z is equal to fx of z into fy of z. So this is equal to minus infinity to infinity fx of alpha into fy of z minus alpha d alpha. So now we will solve this integral. So this is equal to minus infinity to infinity u of alpha minus u of alpha minus 1 into u of z minus alpha minus u of z minus alpha minus 1 d alpha. This is equal to integral of minus infinity to infinity u of alpha u of z minus alpha d alpha minus minus infinity to infinity u of alpha u of z minus 1 minus alpha d alpha minus integral of minus infinity to infinity u of alpha minus 1 u of z minus alpha d alpha plus minus infinity to infinity u of alpha minus 1 u of z minus 1 minus alpha d alpha. So now we get this is equal to integral of 0 to z u of alpha u of z minus alpha d alpha u of z minus integral 0 to z minus 1 u of alpha u of z minus 1 minus alpha d alpha u of z minus 1 minus integral of 1 to z u of alpha minus 1 u of z minus alpha d alpha u of z minus 1 plus integral 1 to 2 minus 1 to z minus 1 u of z u of alpha minus 1 u of z minus 1 minus alpha into d alpha u of z minus 2. So by solving this again and by substituting the values, we get the answer is z of u of z minus z minus 1 u of z minus 1 minus z minus 1 u of z minus 1 plus z minus 2 u of z minus 2. And these are some of the graphs for f of z that we get. And as we have shifted the result right, in the final result, we get f of z is equal to z minus 1 u of z minus 1 minus z minus 2 u of z minus 2 and z minus 3 u of z minus 3. So 2. Further, so now we have gotten the answer as this by solving by the convolution method. Now by the geometric method, we get these possibilities. Now in the first case, the answer would be this area, which would be half into z, which is z square by 2. And after we take the derivative of this, we get z. Then in the second case, that is 1 less than z less than equal to 2, we get this area, which would be the answer. So this becomes, this is equal to f of z is equal to t of x plus y less than equal to 2 is equal to z square by 2 minus z minus 1 square by 2. So over here also we get the final derivative as minus z plus 2. Then for this third case, we get this graph. So, and we get f of d of the derivative of d of with respect to z, f of z of 2, we get as 0. So after we substitute this, after we shift right, This by right we get fx of x is equal to u of x minus 1 minus u of x minus 2, f y of y is equal to u of y minus u of y minus y. So from these three possibilities, we get the final answer of f of z is equal to z minus 1 u z minus 1 minus 2 z minus 2 u z minus 2 plus z minus 3 u z minus 3. And this is the final graph.